Welcome back. In today's lesson, we're going to be talking about variables and expressions. So more specifically, in this example, we're going to be talking about how to actually write algebraic expressions to reflect certain statements. Now, I want you to be very clear. In this lesson, we are not solving anything. We're only writing expressions. So let's get started. In this one, I'm going to start off with a formula that you're actually already familiar with. So think of the rectangle, think of when you did area and perimeter. You were already working with algebraic expressions. So if I bring you over here, you know the formula to calculate your area is base times height. B standing for your base, H standing for your height. Well, that's an expression. And the same thing with a perimeter. Perimeter equals 2 times your base plus your height. Again, those letters are representing certain numbers, and that is why you have an algebraic expression here. Now, you've heard me say the word algebraic expression a few times. That's a word I want you to remember. So when we're dealing with algebraic expressions, we're talking about statements that you're actually writing to reflect different scenarios. In this case, n and x are what we call variables, and we use them to represent certain numbers. They could represent any number, all right? In this case here, we already have an algebraic expression of 100n. And as we go into my examples, we're going to talk about how we come up with expressions like this. But remember, these are called algebraic expressions. I'm not solving for anything. All I'm doing is writing the statements. So let's get started. Example number 1, I want you, now see if you can come up with how to write these statements before I even give you the answers. So number 1, we're going to have here, there are 3 more than a number. So again, when you start along with these scenarios, try to think of what operation is this question asking, and how are you going to use those variables in those sentences? So here's the example. So again, there are 3 more than a number. So it can be written like 3 plus n, meaning n will stand for that number, or n plus 3. And you know, for addition, I can write this scenario, the algebraic expression, either way, and my answer will be the same. But notice my variable is remaining as n, and the 3 is the constant because that's what's up here. Let's go down to the next example. 7 times a number. So again, think about what operation. I have times here, so now I know it's multiplication. And now I'm thinking 7 times. So 7 times whatever that number is. And here is my answer. 7 times a number, 7n. That n standing for a number, and 7 is right up here. Now some people, they will also take those expressions and write it like this. So they'll actually put the multiplication sign in there. You can do it, it's completely fine, but it's just very, very rare to do. I would rather see you get used to writing the algebraic expressions like this and know that between my variable and my number, that there is a multiplication sign that's in there. Let's go on to the next example. So we have 8 less than a number. Now, here's on these types of questions, I'm going to tell you be very, very careful, because I have that key word less, which is dealing with subtraction. So any sort of algebraic expression what involves subtraction, be very, very careful, because you do have to write it very precisely. When it was adding, we had some flexibility. You could put the variable before or after the number, it didn't matter. But with subtraction, you don't have that variable, because if you write it wrong, then it doesn't go along with what we have up here. So here is the answer. So 8 less than a number, so that number is my variable, and 8 less, I have that subtraction at the end. Let's go on to another example. 20 divided by a number. So again, think about the operation. I have divided, I have the number 20, and I have my variable, which I know is going to be an n that's floating around somewhere. This is what the algebraic expression is going to be looking like. There's the 20 divided by, we have this sign here, a number, and that's where my variable is. So 20 divided by a number. Now let's see if we can take this writing of algebraic expressions and actually apply it to word problems, because this is most often where you're actually going to be using them. So in this scenario here, I have a car that's traveling at an average speed of 50 kilometers an hour. I want you to tell me how far will the car travel in 3 hours, and then how are we going to write that as an algebraic expression. So if I do some quick calculations here, 50 kilometers an hour, 3 hours. If I multiply the two together, I know that I'm going to be traveling 150 kilometers in those 3 hours. All right, that's your number sentence, that's your answer, we've got it. But the question is, I want to be able to write down an algebraic expression to go along with this. And this is where this part here comes into play. If you take a look down here, I'll try to circle it here, 50t, that's the expression that goes along, and you could use this to help represent how you can solve this. 50 standing for the number of kilometers that you would go for an hour, and t standing for the number of hours that you're going to be traveling. In this case, t stood for the 3. So this is how that would reflect that word problem. Let's go ahead and do a few more examples here. So I want you to write an algebraic expression to show the amount of money earned at $5 an hour. I want you to use the variable t to represent the time worked. So if you think this through, again, I've talked a little bit about this, so I'm going to harp a little bit more on showing the algebraic expression like 5t. 5 being you're going to be earning $5 an hour, and t standing for whatever number of hours that you're going to be working. But that's the expression that you're going to be using. If I want an algebraic expression to show what the perimeter of a square is, I want your variable to be s, and that's going to stand for the side length. Now keep in mind, this is a square, and all 4 sides are the same. So that's where you have this equation that's come into play. 4 standing for the 4 sides that are identical, and s standing for whatever length it's going to be. Right now, we don't know what that length is. That's why we have the variable s that's going in there. Your next example here, 8 more than 3 times a number. Now, I should warn you, I'm going to get to my last 2 examples here. These ones are going to be a little bit more complicated than the first ones, because these algebraic expressions are going to be a little bit longer. They're going to involve 2 parts, which means when you have a statement like this, consider it in parts, because there's 2 different operations that are going to be coming out to create a lengthier expression. So 8 more than 3 times a number. So if I pull something out here that I can do fairly easily, I see 3 times a number. That's something that we've already been doing on the previous slide. So I should be able to do that, and I have 3n. But the first part here, 8 more, I still need to put into the expression. Now that word more stands for adding, and this is where I'm going to put that at the end, and I'll bring this down. So I'll circle the answer that we have here. So you have the 3 times a number, but at the beginning it says 8 more. I have the plus 8 at the end. Now some of you might be wondering, can I put 8 on the other side? You can. It's not done too often. If you do it, will it be wrong? Absolutely not. All right, like I said, when you have adding, you have a little bit more flexibility, but when the subtraction occurs, that's when you have to be a little bit more precise. And speaking of subtraction, our last example here, so let's take care of this one. So double a number and subtract 5. So I'm going to deal with the subtraction last. I want to focus on double a number. Now, n is the variable. It's going to stand for whatever number we're talking about here. But that keyword double, I'm going to think 2 things. I'm going to think multiplication, and I'm going to think of the number 2. So when I'm doubling a number, this is the first part of the algebraic expression that I'm going to be writing, 2n. You're going to double a number. You're going to take that number and you're multiplying it by 2. That's exactly what I'm asking. And then the last part here, when you're subtracting 5, I told you before, you got to be very careful where you're putting it. In this case, the subtracting 5 is going to be at the end. So this is where my subtraction 5. So double a number, subtract 5. We're doubling a number, we're subtracting 5. Exactly what's up there. So there you go, a lot of examples that shows about how to actually create algebraic expressions. My advice to you is when you are writing algebraic expressions, remember 2 things. Number 1, you're not solving it, but 2, you need to read very, very, very carefully what is the question and asking you. And if it's a little bit more longer ones like this, take it in sections. So good luck, and we'll see you in the next episode. Bye.